now recording. Go back to share screen. All right, so let's take a look at this problem here. So I'm going to go through this. After I finish going over this, then I'm going to let you guys, I'll probably pair you guys up, because it's perfect, we got 4 people, and have you guys just work through another problem that's kind of like this. I have it on the 2013 exam. So here you have the graph of f. That's fine. And they're saying that let g be the integral from 1 to x of ft times dt. So the first thing they ask is find g of 2 and g of negative 2. Here's what you're going to want to do for this kind of question. The first thing you want to do in the College Board, and this is definitely from the horse's mouth, because I've been on these workshops and spoken to people who grade this stuff. You're going to want to take this and immediately say this. That's the first thing you're going to want to do. This shows that you understand FTC. That is what the Fundamental Theorem of Calculus is all about. So more formally, usually it's written like this: d of dx of some function or actually, hold on, let me take that back. So it's almost like the derivative and the antiderivative knock each other out here. Another way you could think about this too is if you replaced this with a capital, actually, let me write it down here. If you did something like this here, which we kind of know how we handle a definite integral. So that's another way of looking at FTC. So that's exactly what's happening here. But shorthand, just do this. That they're going to give you some points by showing that. So I did a more formal bit over here, but obviously you need to know that. But that's what you need to do. So now in this case, I'm asked to find g of 2 and g of negative 2. So, well, g of 2 is simply an integral, right? I'm just going from 1 to 2 of f of t times dt. So if we're going from 1 to 2, I'm only looking at this part right here. Now the area, just the area of a triangle, which I know is 1/2 times base times height. And it is going to be negative because it's below the x-axis. And we're going from left to right. It looks like my base is 1. And my height, based upon the slope I'm seeing here, looks like it's a slope of negative 1/2. So my height's going to be negative 1/2 as well. Sorry, just 1/2. So it's going to be negative 1/4. So for part A, g of 2 is just negative 1/4. All you're doing is just taking the area of the triangle from 1 to 2. So you're doing that geometric calculus connection. That's important. Now g of negative 2 is going to be kind of a fun one. The reason I say that is that the order is reversed. Your lower limit is actually higher than your upper limit, if that makes sense. So in this case, I'm going to erase this triangle. I don't need to really focus on that and erase this here. I don't need that either. And I'll erase that. So I'm going from negative 2 to 1. So I'm focused on all this and all this, but it's reversed. So I'm going to actually do this instead. Because that shows the understanding that, oh yeah, I'm reversing the limits of integration, so I got to put a negative next to the integral. That kind of keeps things a little bit clean. And then you just got to find the area of the triangle plus the area of the semicircle. Now, the area of triangle is easy. That's 1, and the height's 3. So that's going to be 1/2, oops, times 1 times 3, plus the area of the semicircle has a radius of 1, right? So it's 1/2 pi 1 squared. So in essence, I'm getting negative parentheses 3/2 plus pi over 2. And that would be sufficient in giving your answer for part A. Any questions so far about what I just did for part A?
When you are taking the integral and it's below the x-axis, don't you?
Oh, you're right. Yes, thank you. I made a mistake. Okay, actually, let's look at how many points I've lost for that mistake. So thank you, Jessica, for catching that. Good, you're paying attention. All right, so yes, I goofed. That should have been negative right there. Good catch. And then that means that this should have been negative right here. Come on, here we go. And you can leave your answer like that. That's totally fine. In fact, you're probably better not rounding because they do have this thing that if you do give a decimal answer, it has to be the 3 decimal places. I just leave an exact form. You don't have to simplify. They don't care on the AP. And given that they want to grade these quickly, I don't think they're going to really mind. Now, let's look at how this would have been scored. So let me do a quick screenshot here. Call this and let's go here. It's not number 1, it's number 2. Sorry, it's number 3. I'll change that later. Okay, let's go and clear this. Oh, there we go. Okay. Yeah, so we look at the solution key really quickly, just so you get an idea of some of the scoring for that problem. So it was only worth 2 points. I probably have lost a point. I've only got 1 out of 2 points on this. You can see why the scoring. Actually, I haven't shown you. I haven't shown you guys. Let me do this actually. I'll have to look in a document. There's a document that kind of shows the scoring distribution for every problem. Sometimes the average for each of these questions is pretty low because it's hard to get 9 out of 9. So my guess is this will probably be worth not more than 9 points because they're going to make this a 25-minute question. But usually what they try to do is to make these questions worth 9 points. And they kind of figure out how to distribute the points. And so G of 2 was worth 1 point. Again, G of -2 is worth another point. Even if you did all the work correctly, all those stuff, if you had the wrong final answer, you have received nothing. So I would have only got 1 out of 2 for that very stupid mistake on my part. So you do have to be very, very careful. They don't really give the same kind of partial credit that you would in a high school class. Like personally for me, in my, when I taught AP Calculus, for G of -2, I would have made that worth maybe 4 points. And for that mistake I made, I've given myself maybe 3 out of 4, 3.5 out of 4 points. Yeah, I would have received nothing. So, so you do have to be very mindful about that. Let's keep moving. Let's look at part B. So we already established again that G prime equals F and G dou prime equals F prime. I'm getting a little more lazy now, but that's okay. And if you wrote that, that's fine too. We'll totally accept that. So G prime negative 3 is simply going to be F of negative 3. And G double prime negative 3 is going to be F prime of negative 3. Again, by taking the derivative of both sides here, or by doing d of dx here and d of dx here, the right side becomes f of x. That's why g prime equals f of x. And if you do the derivative again, then g dou prime is f prime. So make sure you guys are comfortable with that. That is very, very important. That is probably going to be the big thing that you really want to assess on this test. It really is the whole essence of calculus. But it's easy, you know. F of negative 3, just look at it. You know, there it is. So it's just 2. That's all. And then f prime negative 3 is going to be the slope. The slope there, of course, is 1. And you may want to just give a quick explanation, you know, something like that, you know, whatever. But didn't ask for an explanation, so you didn't really have to say anything about that. So that should be sufficient. Yeah. So you get 2 and 1. And but see, notice they showed that. So that's very, very important that you make that connection. If you just wrote the answer, I don't know if you've got the point, but better safe than sorry. You know, definitely make that connection. That G prime is F and G dou prime is F prime. Okay, so that covers part B. Any questions there on that one? Nope. Okay. We'll do a quick screen capture, and then we'll move on to part C.
If there was a question like that and it did not exist, explain why it didn't exist.
Oh, great question. Most likely, okay, what if I did this to you? That's a fantastic question. I'm glad you asked that. They could ask that. What if they asked you to find this? F prime of negative 2 and F, sorry, I didn't mean to say that. I meant to say G prime of negative 2 and G dou prime of negative 2. Now, G prime negative 2 is F of negative 2. Well, of course I know what that is. That's 3. This is going to be F prime of negative 2. What's the problem with that? Why is that a problem to find F prime negative 2?
It's a corner.
It's a corner. You're not differential at corners. That does not exist because the left-hand derivative will not equal the right-hand derivative at corners. That would be your explanation. That's the reason why. So that would be one possibility. You probably said the same thing could have happened at -1, at 1 as well. If they ask for the endpoint, it still exists. And you use the appropriate one-side derivative. Like if they ask for f prime and negative, sorry, g dou prime and negative 4, which is of course f prime negative 4, you would say it's 1, but you'd say because of the right-hand derivative, because it does exist. Or if they ask for f prime of 3, then you'd say, okay, it's going to be 1/2. Sorry, -1/2, using the appropriate left-hand derivative there. So that would be a case in which you get does not exist, or if there's a hole, or if there's a jump, that would be other reasons too. But yeah, but that's something I could see happening for sure. Okay, let's look at C. Find the x-coordinate of each point at which the graph of G has a horizontal tangent. Okay, so remember, G prime equals F. Horizontal tangents happen when G prime equals 0, because that's the slope of the tangent line. That only happens once, right there. So that's easy. That's going to be at x equals 0. So you want to say that at least. And And I don't think that's going to happen anywhere else. Nope. And then you need to say, wait 1 sec, hold on. Darn it. Sorry. I just thoroughly confused you guys. Sorry. Okay. Yes, G prime equals F. You want G prime to be 0. So you want F to be 0. That happens twice. I messed you guys up. That was my fault. What I was doing actually was a second derivative. So I apologize for that. And actually, that's going to be part D. So my apologies. I caught myself when I read the second part of the question. Because like, well, wait, no, that doesn't make any sense. So I caught myself there. So that was my fault. My apologies. So yes. So hopefully that makes sense. G prime is F. You want G prime to be 0 for horizontal tangent for G. That means F has to be 0. So where's F 0 or Y 0 on this graph? At -1 and 1. So that's the first thing you have to do. Then what you have to say is whether it's relative min or max. So you'd want to say that G has a relative min at x equals, actually it's going to be relative max. At x equals -1 because F changes, or hold on a sec. G prime, we'll just say this. Because G prime or F changes from positive to negative at x equals -1. You have to say it that way. Very, very important. They're extremely strict about how that is assessed. Essentially, you need these 3 components. You gotta say whether it's relative max or min. You gotta say where it happens, and you gotta say the statement that's changed from positive to negative. You gotta say those things. Very, very important. It probably would help to restate where the change happens, just to be on the safe side. But you gotta tell me whether it's a relative min or max. You gotta tell me where it happens, and you gotta tell me how it changes. So basically 3 things. Relative max / min, or neither. X equals somewhere. And how the change happens. You got to hit on 3 of those things. That's only probably worth 1 point though, is my guess. I think this is probably, I think they probably gave a point for each explanation and a point just for getting the x values all together. So it's probably worth 3 points. I'm going to show you how to do the second part of this problem in just a sec. But you do need to say it in that manner. Really quickly, at x equals 1, you guys think that's a max, min, or neither? Someone could just chime in.
Min.
Well, F is negative both before and after. Because the sign, so the sign doesn't change for F, right? Because remember, G prime is F, and we're looking at the graph of F, so there's no sign change at all. So it's going to be neither. So you would say at x equals 1, there's neither a relative max nor min because G prime or F does not change sign.
Shouldn't x equal 1 be the relative max? And x equals -1 is
Well, no, but we're looking at for G though, right? So for G, so G prime is definitely 0 at 1 because that F is 0 at 1. But you're looking at the sign change. So you're looking at the you're thinking of F prime, or F itself. F itself does have a positive slope here, and then negative slope. So the slope of F does change, but we're looking at G though. That's what we're more interested in. So if we look at like how they express this in the answer key, you can see it's neither. So what you're doing again, I think what you're doing is that you're looking at the tangent lines at F. You have to actually think of it as G prime, which we don't know how G prime looks. So we make that connection. G prime is F. And so how does F change sign? The Y value of F, not the slope. The Y value is negative right before 1 and negative after 1. So there's no change whatsoever. Let me take a quick screen capture and show you the answer key for that one really quickly. Let's see here, save. Okay, and let me clear this out. Yeah, so if we look at the answer key, so 1 point just for giving the answers. The justifications actually altogether were worth just 1 point. So I think they might change the scale a little bit and might give a little more credit for that, because it would suck to really have this right and have this wrong. But notice he had to say there's a sign change from positive negative x equals -1, and therefore it's relative max. Or here, there's no sign change for G prime, so therefore there's neither max nor min. And of course, he had made that establishment G prime equals 0, but we did that earlier on. So just have that somewhere, G prime equals 0. So that's C for that one. Okay, lastly, D, before we do a practice problem, that's very similar to this one. Okay, point of inflection. Okay, that's where I made my mistake earlier. So remember, for a point of inflection, G dou prime has to change sign. It's not where it equals 0, very important. Point of inflection is not when G dou prime is 0, because you could still have things, if you had like a weird piecewise function, you can still have things still look concave up the whole time, concave down the whole time. G dou prime must change sign, or F prime must change sign. That's what has to happen. So right now, F prime here is positive. Here, F prime is negative. F prime is also negative here. But now F prime is positive, and then F prime is negative. So how many times does F prime change sign? Once, twice, or 3 times?
Three times?
Yep, 3 times, very good. Yep, definitely 3 times. It changes sign right here, and right there. So you would say x equals -2, 0, and 1. You get 1 point for that. And then you have to say because G dou prime changes sign, or F prime changes sign at those x values. If you said that, you would get full credit. And I think you might want to make that establishment that G dou prime equals F prime. That's why I always kind of tell my students, just get that out of the way first. Just put it anywhere in the paper. They'll give you points for it. Yeah, -2, 0, and 1, because g0 prime equals f prime, change sign each of those values. There you go. That's exactly 1. So it's one of the problems that AP students sometimes have a hard time with it. I think mainly because there are a lot of people take the AP test who probably not really well equipped to take the course, or maybe their instructor doesn't really do the best job of telling them, you know, the rubric and what the College Board graders are looking for. But you know, that's why you really want to practice on AP style exams and, you know, old exams too. Yeah, I think this is a good problem because it does take care of you know, integration in some bits, because we had to do some integration part A, obviously, and do that geometric connection and knowing the directions. Definitely takes care of fundamental theorem of calculus. Definitely takes care of knowing how to establish sign charts, relative mins maxes. You don't have to show a sign chart. I didn't do one. It also takes care of second derivatives and concavity, points of inflection. So a lot of different things are happening here. Let me do another screen grab. And we will definitely go over other problem types too over the other sessions. I just think this is just one of the quintessential questions. So my plan is on Mondays to do questions like this, Wednesdays to do more serious questions, and then Fridays I'll just kind of pick some sort of random topic, just so you guys, you know, kind of see everything. Okay, any questions about that one? Nope. Okay, so this is good timing. So what we're gonna do, I'm going to leave this on my screen. This is a 2013 exam. We're going to look at, hold on a sec. Yeah, there we go. Actually, okay. Okay, here's number 4. Let me kind of just give you the lay of land here. So now they give you the graph of f prime, the derivative of a twice differential function f, okay, on the closed interval, which is kind of similar, right? Because we looked at the graph of f, which was actually g prime. So it's kind of similar. They tell you where you have horizontal tangents. They give you the areas for different regions. They also tell you f of 8 equals 4. So to kind of give you a little bit of a push here, this will be important to say, is that the integral from, say for example, I did A to 8. So that's going to be a very important connection to make here, is that, oh, that was dumb. I don't know why I did that. Because you already have a derivative. Yeah, so that's a very important distinction you're going to want to make. Is that when you take the integral from a to 8 of f prime t times dt, it's going to be f of 8 minus f of a. So if you happen to know the area, say for example, A were like 6. Well, I know the area from 6 to 8 is 7. And f of A I know is 4. Then I can solve for f of 6. F of 6 is going to be just -3. So that's something that may help down the road. Okay, so you guys should have a copy of this. I emailed it to all of you guys, and I also have a Google Drive folder. So I'm just going to just randomly put you guys in pairs, so get to know each other. So let me close that. Let me go to the breakout rooms here. Oh, darn it. I didn't enable the breakout rooms in my settings. Shoot. I did in my other account. That's okay. Why don't you guys just work with each other? Just talk to each other, and I'll actually mute my microphone so I don't distract you guys. But go ahead and work on, yeah, I'll go back to sharing my screen. Shoot, I was hoping to do the breakout rooms. So disappointed I didn't set that up. That's okay. Next time. So here's the problem again. You guys should see it. So go and work on, let's just work on parts A and B right now. If you want to work on your own, that's fine too. But if you want to talk to each other, totally fine. We'll just do A and B. And then we'll check in about a few minutes. So I'll have you guys work on A and B right now. Okay, let's just talk about part A really quickly before we move to get too far ahead of ourselves. F prime is 0 at those 3 places. That's pretty obvious from the graph. and you're looking for where f prime is 0 if you want a local minimum, or I guess where it does not exist. Of those three, which of those three do you feel has a local min? Go, Fiona.
6.
Yep, very good. Yeah, you want to say 6, and because f prime changes from negative to positive.
Would you say that it's a min at 0 also? Because it's
Oh, actually, no, you can't. It's open interval.
Oh, okay.
Yeah. Yes, if it was a closed interval, that's a good point, actually. Then you would say it's a min because the derivative is positive afterwards, so it keeps increasing. Yeah, they did have that, but I think they do open intervals now because I think it just creates too much ambiguity. I think that was a change you made about 7, 8 years ago. Yeah, if we look at the solution key for that one. Yeah, so that's all you want to say for that one there. Okay, so that's good. Let's look at part B. This is going to use the extreme value theorem. Hopefully you guys remember that. EVT. So you do need to know some of those theorems quite well. My guess is they're probably going to do something like that on, if they're going to make this a 25-minute question, where this is traditionally 15 minutes. I think you'll probably see what we did in the 2012 exam, and probably throw in something like this as well, because they really want to test out your knowledge of that. Extreme values happen at endpoints. And critical points. Remember, critical points are when f prime equals 0, where f prime does not exist. Okay, so if we look at what I just did with you guys earlier, so if we f is 0, you could say this, right? Because my endpoints are going to be f of 0 or f of 8. My critical points are going to be f of 1, f of 4, or f of 6. I'm probably not going to waste my time with f1 or f of 4, mainly because it's just going to keep increasing when you get to f of 1, because you have positive area beforehand, and also f of 4 is going to be a relative max, so I'm not going to really waste my time there. But f of 6 is a possibility. But if I do something like this right here, I already know f of 8 is, that's 4. So I already know that. But if I do this part, the area, if I take the whole area, that's going to be 2 plus 6 minus 3 plus 7 equals 4 minus f of 0. So if I solve for f of 0, if I maneuver things, I think I should get negative 8. Yeah, if I do it correctly, I should get negative 8. If I do f of 6, if I integrate from 0 to 6 of f prime of t times dt, that'll be f of 6 minus f of 0. I already know what f of 0 is. Now I know it's 8, negative 8. And the area is going to be 2 plus 6 minus 3, which is going to, close, but it's not going to get us anywhere. F of 6 is going to be negative 3, which doesn't work for us. So your absolute minimum is definitely going to be negative 8. So you'd have to show that work. So I think you'd want to state the extreme value theorem. And in order to state it, you want to say use EVT because f is continuous on a closed interval. You do have to make that statement first, that you're using the extreme value theorem because f is continuous on a closed interval. You can assume continuity. Why? Why can I assume f is continuous?
Because it's differentiable.
Perfect, yes. If it's differentiable guarantees continuity, right? Not the other way around. You can be continuous and not be differentiable if you have corners or stuff, other weird stuff. But yeah, differentiability implies continuity. So you make that statement. I kind of added a little bit more that, okay, you're looking for endpoints or critical points. But as long as you kind of show that you're finding the endpoints, what they equal there, and what the critical points are, you know, or the value of f at the critical points, that should be fine. I probably should have done the, the other ones, but I didn't feel like it. So yeah, those things to the endpoints in f of 6, that was enough. f8 we already knew, f of 0 is -8, f6 is -3. So the justification for sure, saying the absolute minimum of f on the closed interval from 0 to 8 is -8. The answer for sure, and considering 0 and 6. So that's important. Okay, we've got a little bit of time left. Let's look at C. Why don't you guys try C? Any questions about B, by the way? Nope. Okay. So let's take a look at C. So you want to be concave down. So you want f double prime to be negative. You want f prime to be positive. So where does that happen? I'll give you a hint. It happens at 2 intervals. So I will do, let's kind of do the obvious. F prime is clearly positive when you're above the x-axis, and it's negative when you're below, because the graph we have is f prime. We don't have a graph of f, we have a graph of f prime. So make sure always in the f, when you have a graph of f prime, you're looking at the y values. The y values are positive when you're above the x-axis, negative when you're below the x-axis. So we're not going to waste your time looking at anything between 4 and 6, because we want f prime to be positive. However, if I should replicate this, but I don't feel like it. That's where f prime, sorry, that's where f is going to be, or f double prime is going to be negative. Right? So, because you're looking at the slope of the tangent line of the graph of f prime, right? Because you're doing the derivative of a derivative to get f double prime. So what do you guys think are the intervals where this happens.
0 to 1 and 3 to 4.
Got it. Perfect. Yep. And you rise an open interval. And all you have to just say is like f double prime negative, and f prime positive on those intervals. That's usually, I think, should be sufficient. Yeah. This f prime is decreasing. Definitely f prime is positive. I want to say that, but if you say f prime is decreasing, it's the same thing as saying f double prime is positive, is negative. Same thing. But you're saying rate of change is decreasing. That would imply f double prime is negative. Okay, and then we'll wrap this up with D. I'll give you guys a little hint here. So you're trying to find a tangent line for the graph of G, right? So G prime of X is going to be 3 times F of X squared times F prime of X, because you got to do the chain rule. See, this is a great problem because this is a causal way of incorporating so many concepts. Yep, I'll just kind of let you guys think this one through here. So tell me what you guys got. Anyone got an answer you want to share? I think I got it, but I don't know.
Is it 75?
I think it's 75, yeah. I think so. Yeah, because you got 3 times negative 5 halves squared, you know. It's 3 times 25 over 4. And then times F prime, which is right there. So you get 75. Yep. There we go. It's 75. So you get 2 points for actually find G prime of X using the power rule and the chain rule correctly, and then actually getting the right answer. And there's other creative ways they can do this. L'Hopital's rule, which I think you guys have covered. You know, I've seen that kind of incorporated here because I was started a couple of years ago. There's some other ways it can kind of make these problems kind of interesting. So, so I think that covers it for today. Any general questions about what we did? No? Okay. So hopefully you found this helpful, having the live interaction and kind of going through a particular problem. What we'll do on Wednesdays, we'll go over a series problem. Only one slight issue with Wednesday. Unfortunately, one of my former colleagues passed away from coronavirus a couple weeks ago. Really sad. And they're doing a virtual memorial for him at 4 o'clock this Wednesday, which I kind of would like to attend. I'll toss some times around. I'm thinking of like maybe we could do something later, like 6 o'clock, or we could do earlier 1 o'clock. I'll toss some times around and let you guys just let me know. I'll put it as a Google form really quickly to see if we can do an alternative time for this Wednesday. But we'll cover series. That will be the plan for Wednesday. But for the most part, 4 o'clock should be fine. But this is just a rare circumstance, and I would like to be there because it was a colleague I was very close to. And the plans are just, and again, feel free to show up to any one of these. You don't have to feel obligated to show up to every one of these sessions, but I'm gonna make them different and unique. And again, like I'm gonna kind of alternate. I think series and sequences is gonna be kind of a wacky topic, and you guys are gonna see it for sure. I would be shocked if they didn't put that. I mean, because this is what makes BC stand out from AB, is that when they do the series questions. So we're gonna go over one of those types of questions for sure on Wednesday. But I'll email you guys with some different times for Wednesday, just because I would like to be able to attend that virtual memorial service. So anyway, that's it, and I'll see you guys later. Any other questions you guys want to ask? Nope. Okay. So yeah, all right. Then have a good evening, and we'll see you guys soon. And again, watch out for an email from me looking for asking for new times for Wednesday.
Thank you.
All right. See you. You're welcome.
Yeah, thank you.
Goodbye.